Look at this calculation right here. Every single year, thousands of students step into the Cambridge IGCSE physics exam hall and bleed easy marks on energy transfers, efficiency, and power calculations, just like this one. Why? Well, because there's a hidden pattern. Knowing the science and knowing how the examiner actually wants you to write about the science are two completely different things. Today, we're bridging that exact gap to secure your maximum marks, keeping you safely above those terrifying grade boundaries.
So before we even teach anything, I want you to test yourself with this quick poll. Let's say a falling ball hits the ground and stops. Simple, right? But where exactly did its kinetic energy go? Is it A, destroyed, B, dissipated to the thermal store of the surroundings, or C, absorbed by gravity? Take a second and really think about it. Okay, if you chose A, you've got to remember the absolute fundamental law. Energy cannot be created or destroyed. If you picked C, well, remember that gravity is a force. It's not an energy store. So the correct answer is B. And honestly, getting these foundational energy transfer concepts wrong, that puts your exam grade at immediate risk, simply because every single subsequent calculation relies entirely on this core understanding.
And that brings us to the most painful learner mistakes. I mean, it is agonizing to watch students lose easy marks here despite actually knowing the science. Leaving out units and calculations, that's an instant penalty right there. Rounding your numbers way too early in multi-step equations, that means your final answer drifts completely out of the examiner's accepted range. Or how about writing vague explanations like energy is lost instead of saying energy is dissipated to the thermal store? That kind of language will completely cap your grade. And the crazy thing is, these aren't gaps in physics knowledge. They are gaps in exam technique.
This is exactly why ordinary textbook revision completely fails you when you sit down for the actual paper. Staring at highlighted notes for hours just doesn't work because Cambridge examiners are not looking for you to recite fact. They don't just want you to memorize that power equals energy divided by time. No, what they want to see is how you logically apply those concepts to brand new, totally unfamiliar scenarios. Think about calculating the efficiency of a wind turbine or analyzing the thermal losses in a braking car. For them, application is literally everything.
Okay, so here is your absolute first quick win. Locking down these exact variables, equations, and substituted values with standard units is how you guarantee your calculation method marks every single time. Work equals force times distance, and that's measured in joules. Power is energy transferred over time, measured in watts. And efficiency, that's your useful energy output divided by your total energy input, expressed as either a percentage or a decimal. Memorizing these relationships, yeah, that's step one. But always, and I mean always, showing your substituted numbers with their units right next to them on the actual exam paper, that is what secures the points, even if your finger slips and you mess up the final calculator punch. Now, listen closely. In just a moment, I'm going to reveal an incredible hidden examiner clue that changes your final calculation answer completely. Like it literally alters what you write on the dotted line. But first, you absolutely need the answering framework that makes pulling out those kinds of clues entirely obvious. Because without this framework, you'll just be guessing in the dark about what the examiner actually wants. To consistently hit that top end, you need to use this unbreakable four-step procedure for every single written question. Ready? Step 1. Concept. You need to state the underlying physics law right out of the gate, like the conservation of energy. Step 2. Evidence. You pull specific numbers or trends straight from the data table or graph they gave you in the question. Don't just talk generally, use their actual data. Step 3. Scientific reasoning. This is where you connect the concept to the data. You have to explain the how and the why. And finally, Step 4. Examiner wording. Refine your language using specific syllabus terms. So please don't say heat, say thermal energy. Don't say the energy was used up, say it was transferred.
And the syllabus structure itself actually hides a massive hint for us. Take a look at how Section 4, which is energy, sits right perfectly between forces and thermal effects. Cambridge examiners absolutely love cross-topic questions. You are rarely going to get a pure energy question. What you'll get is a question where a force does work to move an object, transferring kinetic energy, which then dissipates as thermal energy because of friction. You really have to train yourself to connect the dots across these different sections.
All right, let's put this into practice right now. I want you to take a moment to pause and predict. Imagine looking at a typical student answer about an electric motor's efficiency that just says, the motor is 0.7 efficient because it loses energy to heat, so the output is 450. I want you to spot the errors there. Think about what we just talked about. Did you catch them? First off, where are the units? 450 watt.
Joules, watts, potatoes? And why is it losing energy? Just saying heat is incredibly vague. That student dropped at least 3 crucial marks right there just from poor phrasing and missing data.
So let's compare that vague, flawed answer to a genuine top-band response. This shows exactly how our 4-step framework fulfills the command words perfectly. A top-band answer would say, the motor has an efficiency of 70%. 450 joules of useful kinetic energy is output, while the remaining energy is dissipated to the thermal store of the surroundings due to mechanical friction. Do you see the massive difference there? It has the core concept, it has the precise data, it shows the reasoning, and it hits those exact examiner terminologies right on the head.
The absolutely crucial point here is that Cambridge command words strictly dictate your output. You literally cannot just describe a data table when the examiner asks you to explain it. If the question says describe, you just state what happens. For example, as the speed increases, the kinetic energy increases. Nice and simple. But if it says explain, you must provide the scientific reasoning. You need to use the formula Ke equals 1/2 mv squared to prove exactly why that energy increases exponentially with speed. If you ignore the command word, you instantly forfeit the marks, no matter how good your physics is.
Okay, here is that key examiner clue I promised you earlier. The magic number 3. You must always check your final answer to ensure you haven't rounded too early during your working out. But more importantly, you have to present your final, polished answer to an appropriate number of significant figures, which in Cambridge physics is almost always 2 or 3. If your calculator spits out 14.56789 joules and you write that entire string of numbers down on the line, examiners will absolutely dock a mark for incorrect significant figures. Stick to 3 significant figures unless the specific data in the question restricts you to 2. It is such an easy mark to save.
Now, for practical investigation questions on energy transfers, think of something like measuring the specific heat capacity of a metal block. You need to run through this final answer checklist to secure those really tricky evaluation marks. Did you include precise units for every single measurement? Are your graph scales linear, and are they occupying more than half the page? Did you account for heat loss to the surroundings as an uncertainty? Did you clearly note safety protocols, like avoiding burns from the immersion heater? And finally, is your data actually reasonable? Keeping this checklist in the back of your mind is your ultimate safety net for paper 6 or the alternative to practical.
So look at exactly where we are right now. We've totally solved the problem of what to write, you know the exact pitfalls, you have the unbreakable 4-step framework, and you know the command words and the significant figure rules. But this leaves a massive, glaring gap. How do you actually write all of this flawlessly when the exam clock is relentlessly ticking down and that sheer panic starts to set in? I mean, having the knowledge is only half the battle. Executing it under strict, unforgiving timing is the true test of a high-grade student.
To conquer that exact timing problem, you have to ask yourself, are you controlling the clock, or is the clock controlling your grade? Seamlessly applying everything we just covered requires a strict timed answer writing system, and the pattern library continues in the next video. So, your mandatory next step is our explainer on the timed answer writing system. Click the video on your screen right now to master your timing. And be sure to subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations.